Today we're going to continue on with Chapter 7, 7.5, Day 1, but we're going to take a little different spin. We've talked about growth decay, we've talked about logs, we've talked about graphing with logs. Now we're going to talk about expanding and condensing logs. So in a sense, it's like we're simplifying these logs. So we're taking them in a sense of equations and either expanding them or condensing them. Now, first thing, a little review. If you can answer these three questions without doing your inverse and without doing your circle, you're doing pretty good. Okay, but if you can't, that's fine. Remember what we do with our logs. Think of this as our circle. Think of this as our inverse to answer this question. What is down here? If there's nothing down here, this is a 10. Remember, that's our definition of a log. So to answer this question, again, if you can't do this in your head, do your circle, do your inverse. So what would this be? 10 to what power would equal 1? Well, how can 10 become 1? What would that be? Do we remember yet? Anything to what power is 1? I don't care if this is 10, x, z, m, 100, 0.5, anything to what power is 1. What would that have to be? That would have to be 0. Anything to a 0 power is 1. Now, we learned a special pattern with this one, okay? But let's go ahead and do our circle first and then go back to that pattern. 5 to what power would equal 5? Well, that one's pretty easy. That would have to be 5 to the first power, right? So that would have to be a 1. But remember, reference that pattern we talked about. We said if the base and this number here were the same, that they just cancel. Well, where do you get your answer from? Well, remember, your answer came from the power that was attached. Well, since there's nothing written here, what would the power be? This would be a power of 1. Okay, so you can do the inverse, you can do the exponential, rewriting as a circle, or if you recognize that pattern, you can cross those off and recognize this power has to be your answer, power of 1. The next one, let's start with our circle. 11 to what power equals 121? Okay, well, hopefully, again, you guys can answer this one for me. This would have to be 11 squared, so that would have to be a 2. Going back to what we said up here with the pattern, if I rewrote this 121 as 11 squared, which it is, these 11s would therefore match. They would therefore cancel, leaving my answer as the power of 2. Okay, again, just getting used to these rewrites, getting used to these inverses, getting used to all these new patterns and stuff that we've talked about. Okay, a little review from what we talked about the last couple of days. Now, again, a little review before we get into the concept for today. The product property, if I give you e squared times e to the 6th, again, how do I actually combine this 2 and this 6? Is it e to the 12th since it's multiplication? Since we're dealing with our powers, remember this is not actually multiplication, this is adding. This means we have 2 e's and 6 e's, so we add them together to give us 8 e's. Okay, well, how about the second one? I have 7 x's on top, 3 x's on the bottom, so how many x's do I have? What do I do with this 7 and this 3? Since it's division, we subtract. 7 minus 3 would leave us with x to the 4th. Now, power property, x squared cubed, a power to a power. Okay, again, what do these mean? This 2 means I have 2 x's. What's this 3 mean? It means I have 3 of whatever's inside of here. So it means I have 3 x squareds. Well, if I have 3 x squareds, how many x's do I have? 6. So power to a power, remember, you multiply. 2 times 3 is 6. We're going to take these properties, and they're going to be almost identical now that we're going to address them with logs and exponents. Okay, so remember our rules. The product property, what did we actually do? We added. The quotient property, what did we actually do? We subtracted. The power property, power to a power, we multiplied. So remember that now when we look at these properties for our logs. Product property. Log base b of x times y. I'm going to be expanding today. So I'm going to be taking this x and this y and expanding them apart. So since this is multiplication, when I expand this, it's going to turn into addition, just like we did on the last slide. Product was actually addition. So this is going to become, when I expand this, log base b of x plus log base b of y. Okay, so let's guess what's going to happen on the next one. The next one's going to be division. It says quotient. But what's actually going to happen? Since the first one was product and we actually added them when we expanded them, what's going to happen on the quotient? Quotient, when we expand them, is going to turn into subtraction. Remember, division means we subtract those powers. So log base b of x divided by y, if I want to expand this x and this y, turns into subtraction. Log base b of x minus log base b of y. Okay, so power property, tell me what's going to happen then. What happened on the last slide? Power to a power, we multiplied. So this one we're going to multiply, but it's going to look a little bit different. Okay, so make sure you watch this one. We have a power of n, and it's going to turn into multiplication. But when it turns into multiplication, it's going to come to the front of the equation to turn into multiplication. Okay, so it does turn into multiplication, but we pull it out to the front. That way it's a lot easier to tell it's multiplication. N times log base b of x. So that power is going to pull to the front and become multiplication. Now, using those three properties I just talked about, and using the two definitions up at the top, log base g of 5, we're going to use as 0.732, and log base g of 11, we're going to use 1.091 to approximate the following. Okay, so they don't want you to type this in your calculator. They want you to use the properties, type in the values that they gave you to get an approximate answer. Okay, so this first one, first thing I should recognize is this is division. Okay, so I've got a 5 and 11, but I need to separate this up before I can actually type these in. Okay, so since this is division, when I separate the 5 and I separate the 11 into log base g of 5 and log base g of 11, how am I going to separate those? With what sign in between them? Since it's division, I'm going to separate it with a minus sign. Now, they gave us the definitions up here to use. So log base g of 5 is 0.732 minus log base g of 11 up here is 1.091. Type them in your calculator, 0.732 minus 1.091. They want us to approximate. Approximate is using those values that they gave us to approximate. Otherwise, the decimals would be even longer. So you type them in, you get negative 0.359. Okay, so just using the properties and using those values. So let's look at the next one. 55, log base g of 55. Well, they don't give us a 55. They give us 5 and 11. Okay, well, but use your head. How can I take this 55, I'm going to cross it out, and rewrite it as a 5 and or 11? Well, 55 is 5 times 11. Okay, so that's your first job, is figuring out how to change this into what you have. 55 is 5 times 11. Okay, well, now what do I do? Whoops, my bad. Log base g of 5, log base g of 11, and then how can I split this up? If it's 5 times 11, how do I split up multiplication? Multiplication splits up with addition. That was our property we just talked about. So log base g of 5 is 0.732 plus log base g of 11 is 1.091. This time, since it was multiplication, we're adding them. Add those two together, 0.732 plus 1.091. You get an answer of 1.823. Now, next one, same concept. You got to rework it a little bit. 25. How can I turn 25 into 5 or 11? Well, 25 is what? 5, 11, both of them? 25 can be turned into 5 squared. Well, you say, well, there's a 2 on that. Well, the 2 is a power. Okay, so what I truly have is a log base g of 5, which is what I need, and the 2 is the power. Well, what was our rule with the powers? The powers did what? Turn into multiplication. So what am I going to do with this 2? I'm going to bring it to the front. So this is 2 times log base g of 5. So that 2 is just multiplication. So 5 squared, pull the 2 to the front. Log base g of 5 is 0.732. And we got to pull that 2 to the front, so now we're multiplying by that. Our answer, 1.464. Okay, so simple plug and chug. Rearrange it with your property and then plug and chug. Now, expanding using those properties. Okay, first thing, if I took this 6 and I pulled it to the front and made this 6 log base 5 of 2x, would that be the same thing as what number 4 shows? And what I'm trying to get at here is if I take it and write it the way I did, this tells me the 6 is attached to the 2 and the x because it's in front of both of them. Well, look at the question. Does this power of 6 actually attach to the 2 and to the x, or does it only attach to one of them? We discussed this many times in class, so hopefully you recognize it's only attached to one of them. That 6 is only attached to that x. It has nothing to do with this 2. So then my next question is this true? Can I pull that 6 to the front and have the 2 and the x on the inside? If it has nothing to do with that 2, you cannot pull the 6 first. The 6 is only attached to the x, so you cannot make it attached to the 2 as well. Okay, well then my question is, if I can't pull that to the front, what do I need to do? Well, before you deal with that power, you need to separate your 2 and your x to the 6th. So I have log base 5 of 2 and log base 5 of x to the 6th. Okay, well, how can I separate them? This is multiplication up here. So how can I split them up? How can I separate them? If it's multiplication, when I expand them, it's going to turn into addition. And now, to finish my expanding, I'm going to pull my 6 to the front. But when I pull my 6 to the front, what do you recognize? It's only in the front of the x. It has nothing to do with this log base 5 of 2 in the front. And that's how it needs to be. The 6 only belongs with the x, like we said up here. So expanding would be log base 5 of 2 plus 6 times log base 5 of x. Okay, let's try another one. Pretty simple. This one's just division. So how am I going to split up this natural log of 10 and this natural log of 3? Well, if this is division, in order to split them up, it is subtraction. Are there any powers? Is there anything else I need to deal with? No. So that's it. Natural log of 10 minus natural log of 3. Okay, next one. Think about it the same way. Can I take this 3 out to the front? Does it deal with all 3 of these? No, so I cannot do that. The first thing I need to do is break these up. So I have log of 3, log of x, log of y cubed. They're all multiplication. 3 times x times y cubed. So since it's all multiplication, they are addition. So log of 3 plus log of x plus log of y cubed. Now, we already said I couldn't bring the 3 to the front because it didn't involve the 3 and the x. It only involved the y. So now look at what you have. The 3 is only attached to the y. So that needs to pull to the front of the y. So I have log of 3 all by itself plus log of x all by itself plus 3 times log of y. That's your expanding. Now, the next one, a little bit different than what we've seen, okay? But what we need to recognize on this one is that I have a root. in order for me to do anything, I'm going to have to change this root to a power, so then I can do the same concept I've done in the past two with the power to bring it to the front. Okay, well that's going to take us back a chapter. How do I take this root and turn it into a power? Well, I've got a 3 and a 5. That root is a power as a fraction. Okay, and do we remember what goes on top, what goes on bottom? The root, does it go on top or does it go on bottom? And which one of these is my root? 3 is the root, 5 is the power. Okay, so which one goes where? Does the root go on top or does the root go on bottom? The root always goes on the bottom. The power goes on the top. So what's this going to look like? X to the what over what? Power is 5. Root is 3. So log of x to a power of 5/3. Since we're expanding, I got to get rid of that power. It's a power, so it moves to the front. So 5/3 times log of x. Okay, the last one. Now, once you get good at these, you can do multiple steps at once. Just be careful when you're doing your steps. Okay, first thing again, can I take this power of 2 and pull it to the front? Hopefully by now you're already saying no, that 2 has nothing to do with the 3 and nothing to do with the y, so I cannot pull it to the front of all of them. I got to wait to do that. Okay, so two things you got to recognize here. I got to break up this 3 and this x squared. Right now it's multiplication. And I also got to break up this y. This y is division. So there's three things. I've got a 3, an x squared, and a y. Okay, so I've got log base 3 of 3, log base 3 of x squared, and log base 3 of y. There's three different terms here that I'm breaking up. Now, making sure we break them up correctly, we expand them correctly. This is 3 times x squared. So when I'm doing my 3 times x squared, all of this goes on the top. Okay? So what am I going to put in between these? 3 times x squared, since it's multiplication, that is going to be addition. Okay, and if it makes more sense to you to put parentheses around them, go for it. Okay, they were both on the top, so you can put parentheses around them if you want to. The y is on the bottom. The y was being divided by. So since the y was being divided by, what goes right here before the y? Division turns into subtraction. So minus log base 3 of y. Now, two things I got to do here. I still have a power. That power's got to come in front of that x, so it's got to come up front. And then second thing, right here, we talked about this on the very first slide of today. Log base 3 of 3. What happens when these are the same? They cancel, and whatever your power is your answer. So what is my power here? This would be 3 to the first power. So log base 3 of 3 cancels. That's just 1. Plus, this 2 is pulling to the front, 2 times log base 3 of x minus log base 3 of y. So that's our rules for expanding. Hopefully you enjoy the lesson today. Here's your homework, 5 through 19. Enjoy the homework. Next one's going to be very similar to what we did today, so hopefully it'll be pretty easy for you guys.